it isn't really novel for my listeners to understand that assumptions can get in the way of understanding nature. And with astronomy and physics and a whole hell of a lot of different scientific endeavors, the assumptions, what you assume to be true, can prevent you from understanding what it is you're talking about. And it can make certain ideas seem as if those are the only ideas available. So naturally, you don't look elsewhere. You don't think, well, there's another explanation for this. No, your assumption prevents that other explanation from being brought to light because you've already painted a worldview upon that you've already accepted to be true long before you actually analyzed all the possible scenarios. And as simple as it is, this one article, Baz wanted me to talk about. Hi, Celeste. Baz wanted me to talk about the space probe that flew past what they call now the Kuiper Belt Object Arrokoth. They call this thing Arrokoth now. Take a good look at that mamma jamma. Huge. Nowhere near as big as a planet or something Earth-sized or the size of the moon, but definitely huge. You wouldn't want this thing crashing into Earth. Would not be fun. It says here, space probe transforms planet formation theory. It transforms planet formation theory. Now, short story, they had two main ideas. The first idea was that they thought back in the 70s that planet formation happened in a violent manner where material slammed together very violently and formed a planet really quickly in the vacuum of outer space from pre-existing rocks slamming together to make a planet. Totally absurd, I know. The second of their main ideas in here is that planet formation happened gently. So you have objects slowly touching each other, slowly coming together. But both are nonsense because they both happen in the vacuum. And they both happen with pre-existing rocks. Now, the main assumption to go over what I was saying earlier in the introduction of this talk is that they assume that this object was two independent objects to begin with. They're assuming that this asteroid is made of completely independent material that's not related to each other, and that the material eventually clumped together. So they're assuming that these two things were not together in the beginning and then they clumped together. That's their assumption. And then they took that assumption and they said, well, did it clump together violently or did it clump together gently? And now they're saying, oh, well, there's two options. There's two options, violent or gentle clumping. Now they're saying it's gentle clumping because there's no major stress fractures. What they have here verbatim, here I'll read it out to you on this little verbatim. See, real relief, preserved fossils, yada yada yada. It gave scientists their first opportunity to test which of the two competing theories was correct. Did the two components crash together or was there gentle contact? And now they say the analysis by Dr. Stern and his team could find no evidence of violent impact. The researchers found no stress fractures, nor was there any flattening, indicating that the objects were squished together gently. Well, what also signals the fact that there wouldn't be no stress fractures or any flattening isn't just that they squashed together gently, but that the material was never separate to begin with. It only appears that they were clumped together in outer space because what actually happened is that when there was a large impact event from two pre-existing much larger objects, what happened is, say you have a planet or a small moon and you have a rather large impactor coming, it will slam into that small moon, creating a huge blast of material going out in another direction. And that material gets hit with such force, with such large amounts of energy and heat, that it liquefies all that rock. And that liquefied rock exits the larger object and starts traveling into outer space. And it can leave that small moon because the small moon's gravitational field is too small. It can't hold on to all that impact remains when it gets ejected from the surface of it. And as that material leaves the surface of that planet or small moon, what happens is it's spinning. So naturally, if you take a rock and you hit a puddle of water, or you throw it in the river, or you throw it in the ocean, or whatever, you get a big splash, right? And if you slow-mo that water from the splash, you'll see droplets flying up. And some droplets will be spinning, okay? And those spinning droplets aren't going to necessarily freeze, okay? But if you had those droplets large enough, they were made of rock, and they could cool in a slow enough time scale, what would happen is you'll end up with asteroids that are double-lobed, like this. You're looking at a frozen droplet that was spinning and froze in place after the impact event. That's all they're looking at. But what they're saying is that it clumped together from gentle collisions. No. That object, that rock, is the remains of a very large impact from some hundreds of billions of years ago, and it's still orbiting in outer space, still probably spinning around, and that's it. That's all there really is to it. But what these researchers are saying is that this object is the remains of the planet formation process that made the entire solar system in one fell swoop, which is totally wrong. The objects in the solar system are all independent objects. They're all stars in their own stage of evolution. The actual process that clumps material together in a star happens internal to the star. So their gentle versus violent collision thing, it's actually both, because when asteroids hit a star, they lose their momentum, and they heat and they break apart and they get broken down, and then that star differentiates that material based off of its properties. And that's why we have something called planetary differentiation. That's why Mars, Venus, Earth, Mercury, that's why they all have a purified iron nickel core, and then the outer layers of pyroxene and olivine and all those minerals and rocks are in the mantle as liquid, which eventually solidify. And then you have the crust with much more exotic material forming from the oxygen, and oxygen makes a bunch of really cool gemstones. But what they're looking at here, this object, isn't the remains of the planet formation process. It's the remains of the destruction of a very old object, and it's still orbiting in outer space in the Kuiper belt. So that object could be somewhere along this very, very low area where I have meteoroids and small asteroids. Actually, medium and large asteroids. That's where it would be. So that middle line right there, medium and large asteroids. So it's somewhere over here along this line. We don't know exactly how old it is. I guess you would have to take radiometric dating samples of its surface. But yeah, I just wanted to point that out to you guys. I'll link that to the bottom. And it just stinks how these scientists, they say it's settled. Where they say it's settled. Felt great, special moment, yada yada yada. Sorry, I should have highlighted this. Let's see. Crap. Okay, here it is. Quote, "There was the prevailing theory from the late 1960s of violent collisions and a more recent emerging theory of gentle accumulation. One is dust, and the other is the only one standing. This rarely happens in planetary science, but today we have settled the matter. Settled the matter. Of course, that's a contradiction. In science, nothing is settled. The very act of doing science means nothing is settled. It's an investigative process. To say something is settled means you quit the investigation. So that tells you right there that they're not actually doing science. What they're trying to do is confirm a pre-existing bias about how they think things work. And of course, they're wrong about it. And all my listeners already know that. In order to form asteroids that are made from pre-existing rocks, they came from highly evolved, very old, dead stars that smashed together way down here. That's it. That's what they're looking at. All right, guys. Today is February 15th, 2020. Take it easy.